Hello friends. So friends, this session is to cover demo for NumPy array creation and doing multiple operations on the top of that. So initially we will start from creating array with by using Python list. So let us first create Python list. We have created one list by using three numbers 1, 2, 3. So this is list. Now we will create array from this list. So ARR, first of all import NumPy as NP. Now in array we have just used np.array. Within bracket you have to give this NumPy this Python list, and by using this Python list it is just creating array. So this becomes one dimensional array. Suppose we have to create multi-dimensional array by using Python list. Now this is Python list. If we suppose import this into array, so by using this list it's creating multi-dimensional array. So this is one way to create array by using Python list. Another way is like numpy.arrange. Arrange is a function in NumPy library. This is very powerful library for numerical and array operations. So this library is used to create an array with evenly spaced values within given interval. Like for example, its syntax is like start, stop, d type. Start is optional. In start we can mention start of the interval like 0. By default it takes 0. Then stop, suppose in stop we are putting value which is end of the interval, right? Then step is like how many steps, like spacing between two values. So by default it takes 1. Then d type is data type of the output array, right? So let's look into one example. If suppose we have taken np.arrange 10, so by default it will start from 0 and 10 numbers till 10. So 0 to 10, and by default it's taking step as 1. Now suppose in this example only, if we are just doing some changes, number starts from 2 and step is say 2 and end we have taken as 30. So how it is returning starting from 2 till 30, step 2 2. So this way it's generating array. You can take decimal numbers here as well, that it will take decimals values, or maybe if this array you want to convert into decimal, you can put here d type. D type equal float, then now it's showing 2 dot this way, that is float type. By default it takes integer type. So this is used to generate sequence of numbers mainly in array or in matrices wherever required. Next is np.zeros. np.zeros is used to generate array with all zeros. So now we have to mention here like what how many numbers are required in array. Suppose I have given here 4, so it's taking one dimensional array 0.0.4 numbers. Similarly we can give here for 2 dimensional. So it has generated 2 dimensional array with zeros, all zeros. And this is not only for zeros, you can give ones as well. Once it's giving 1 dot. Same way for multi-dimensional as well, we can give ones. So NumPy.linspace is a function in library. This function is used to generate array of evenly spaced values over a specified range. So linspace means linear space. So when we are creating array with this, then we have to mention 3 parameters: start, stop and num. So suppose start stop means from 0, suppose I have mentioned 0, 10. So from 0 to 10 it will give numbers in between that range only. And third parameter is number, like how many numbers are required. Based on that it start doing equally spacing between the numbers. So let's look into one demo. So here a start is 0, then 10, start is 0 till 10, 5 numbers. So it has equally splitted the numbers. Suppose we increase this number. Now again if you can see here 0, 1.11, 2.22. Suppose I increase this number to 100. So in that case it will generate equally distant values. So next is identity matrix. What is identity matrix? So this is square matrix, like a number of rows, number of columns should be equal, and identity means in one diagonal all diagonal elements should be 1. So such type of matrix is called as identity matrix, wherein from left to right one diagonal is all 1, and then this is square matrix, number of rows and number of columns are equal. So you can create identity matrix by using numpy.I function. So I function takes one parameter, which is number of rows and columns. For example, if I have given 4, it means it will generate array of 4 by 4, because this is square matrix, square array, square matrix, right? So it always generates 2-dimensional square matrix only. Suppose I have given here np.I3, so it will generate 3 by 3, and this diagonal is 1. If you just increase this number accordingly, it will generate square matrix only with identity. Next is random number. Random numbers of uniform distribution from 0 to 1. So NumPy, within NumPy there is function random. NumPy provides otherwise different functions to generate random numbers with different distribution, but one best function is numpy.random.rand. It generates random numbers from a uniform distribution in range of 0 to 1. So we can just look into one example. Suppose if I am writing np.random, np.random.rand, suppose here 5 is written here, so it will generate numbers from 0 to 1 within that range, and 5 numbers which are equally distributed, right? So this way it will generate random numbers. If this 5 is increased to say 10, so accordingly it will generate numbers within the range of 0 to 1. Then this is not only for one dimensional number, we can create two dimensional as well. So for two dimensional we have to just give here two numbers here, 4 by 4. This is not only to generate as a square matrix, you can have different numbers as well. So this is two dimensional array generated with random numbers. Similarly, there is another function randn, which is used to return from non-uniform standard distribution. If suppose I am not writing any parameter here, it will give one number, or suppose if we give 3 parameter or some other parameter, so accordingly it will generate one dimensional array with 3 different numbers, right? And this example is basically for one dimensional. Similarly, we can have two dimensional as well. And if we use randn is used to generate non-uniform numbers. You can see here difference, like one number is positive, then negative, then positive, so it's non-uniform distributed numbers. So based on requirement we can use different functions here. So in randn there is one more thing, that when we see a non-uniform distribution, so how it does, like by using standard Gaussian distribution with a mean of 0 and standard deviation of 1, it generates number with standard normal distribution, and also it produces random number which is normally distributed within range of 0 and 1, right? So this way its logic is to generate random number based on standard normal distribution only. For two dimensional array, again random works here. So it's generating now it's now generating two dimensional array. So next is randint. Randint is used to generate integer numbers only. Suppose we have given here parameters 0 to 50, so it will give numbers between range of 0 to 50, and then how many numbers would be there? 10 numbers. So these all random numbers are in integer numbers only, right? So next method is reshape method. So how reshape method works, like if suppose we have two arrays, single dimensional, multi-dimensional, so we can reshape arrays, right? How to do that? Let's look into example. Suppose this is the array like rand int 0 to 50 and total 9 numbers are there. So how we can reshape this array? Because if we print here, this is showing one dimensional array. Now to reshape it, these are total 9 numbers, so how to reshape it? Nine means 3 by 3, and let's keep it in different array. Now if you run this, so it's showing whatever numbers coming from here, it has reshaped those numbers by using 3 by 3. If suppose instead of 3 by 3 we use 2 by 3, because first 6 numbers it can take, but it will not take, it will give error, because exact 9 numbers, for consuming 9 numbers, which type of array is required, that dimension we have to give here. Now we can use max function to get max number from array. This is to get max number and this is to get min number. So max number is 42 and min number is 0. Now suppose I need index number where this max number is present. So for this we can use argmax. So argmax is like in array. So let me print array here. So argmax is say maximum number is 42. 0, 1, 2, 3, 4, 5. Fifth index number. Similarly, suppose I need to check minimum numbers index number. So here minimum number is 0. So 7th. So this is correct. 0. 0 number is on 7th index number. So this is the way to identify index number of minimum number. So friends, these are all mathematical operations which we performed on arrays by using NumPy package. We use different functions. So we learned random number generation, generate array from Python list, and also we used reshape. Then we used identity matrix, how to create that, and then zeros, all ones, and what are the different ways to generate arrays and reshaping those arrays and identifying maximum minimum numbers with index numbers. So all these mathematical operations are important to work on doing some calculation or maybe storing numbers in the array and then further doing calculations on the top of that. So hope this video is helpful for you. We have lots of other mathematical functions in NumPy package which we will cover in upcoming videos. So thank you so much for watching this video.